Welcome back. This is AG3, Chapter 8, Section 6. We're looking at proportionality theorems. So our essential question has a lot of math terms in it. What proportionality relationships exist in a triangle intersected by an angle bisector or by a line parallel to one of the sides? So we'll start off with the first theorem. So our first one is a triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So what this is saying is if we have a base QS and we draw a line through the other two sides that's parallel to QS, and it's indicated by these red arrows, and that's what this says right here. If TU, segment TU, is parallel to segment QS, then this ratio holds. The value from RT written over TQ is going to be equal to the value of RU written over US. So whatever numbers or values that we know for these lengths, we can write a proportion out of them. They're going to be equal to each other. We also know the reverse, that we have these ratios, RT over TQ, and it's equal to RU over US. We can say that these two lines are parallel, and that's what this section says. I think this is easier to see with some numbers, so let's try it with some numbers. So we want to find the length of a segment. In the diagram, segment QS is parallel to segment UT, so we know that these two are parallel, and it's indicated by the red arrows. RS equals 4, ST equals 6, QU equals 9. What is the length of RQ? So because of this, we know that these two are parallel. We can use the first part right here, and we can set up these two ratios. From the point down to our first segment, we can write them over each other's proportions. So we're starting at the point. RQ over QU, RQ over QU is equal to RS over ST, RS over ST. Now we fill in the numbers. We got RQ over 9, RQ, we don't know RQ, so we leave it. And then we got 4 over 6. Now what I would do here is instead of writing RQ, I would write X over 9, because that's an unknown, equals 4 over 6. And now we can use our butterfly to get an equation here of 6x equals 36. And now we can solve by dividing both sides by 6. X equals 6. And that's what we got here. RQ equals 6. So we use our definitions, and then from our definitions we plug in our known values to get an equation, and from our equation we can solve. We have another theorem that says if three parallel lines intersect two transversals, then they divide the transversals proportionally. So what this is saying is if we have 1, 2, 3 parallel lines, and that's indicated by the triangles, then UW written over WY is equal to VX written over XZ. And we can see this through an example. In the diagram, angle 1, 2, and 3 are all congruent, so that's indicated by these little circles, partial circles. GF equals 120 yards, GF equals 120, DE equals 150 yards, CD equals 300 yards. We want to find the distance from HF between Main Street. So we can set this up. We have three parallel lines. We have 1, 2, 3 parallel lines cut by two transversals, and we can set up these ratios. So we know HG over GF equals CD over DE. So HG over GF, and GF is 120, equals 300 over 150. And once again, I would set this up using X over 120 equals 300 over 150. And from here, we can do our butterfly, once again, to solve for X. And then we'll find out that HG equals 240. And then we add the 240 plus 120 to get 360, because they want the whole value from here to here. look at forms and the assignments, looking for 8.6.1, and that'll be our last assignment. When you're done with it, let me know so I can get you the quiz.